Welcome to our video. This video it describes the types of fluid based on the viscosity. I am Dr. Suresh Kumar, Associate Professor, Department of Mechanical Engineering, Ramco Institute of Technology. So these types of fluid, we have two kinds of fluid. One is Newtonian fluid and another is non-Newtonian fluid. What is the Newtonian fluid? Newtonian fluid, it obeys the Newton law of viscosity. What is Newton law of viscosity? The Newton law of viscosity, it says that the shear stress of the fluid, shear stress occur in the fluid here, and the shear stress is directly proportional to the velocity gradient. That proportionality is removed, the constant of proportionality multiplied, that proportionality is called, this is viscosity, dynamic viscosity or absolute viscosity. So this law states this law is Newton law of viscosity. This Newton, whichever the fluid it obeys this law, it is called the Newtonian fluid. If it is not obeyed this linear relation of shear stress and velocity gradient, that is called non-Newtonian fluid. So non-Newtonian fluid and non-Newtonian, these two are fluid based on the Newton law of viscosity. We have this divided. And first let us see about the Newtonian fluid. Newtonian fluid, as we know that, as I said, it obeys the Newton law of viscosity. That Newton law of viscosity here, CSS is directly proportional to this rate of shear strain or velocity gradient. So when we take these two parameters in the curve here, and this in y-axis, x-axis is a velocity gradient and is an independent variable, but here shear stress is dependent variable. Shear is depends on the velocity gradient here, or rate of shear strain or rate of shear deformation. As here this curve is represented the air. That slope of this one is called here, this is the slope. The slope is called dynamic viscosity. And you can see another curve is here, is represented a gasoline engine, a gasoline fluid, and another curve is this is water, and mercury, this is crude oil. These are all the fluid is called Newtonian fluid, which obeys the Newton law of viscosity. That means it is a linear relationship between the shear stress and the rate of shear strain or velocity gradient. See why it is in different nature. This curve is shifted to here and here. That means, as we know that, as I said, this slope is dynamic viscosity. So gradually this slope has increased. So slope increase means the dynamic viscosity of the fluid has increased. See here, air is a low viscosity fluid as compared to this, and water is a higher viscosity than air and these two fluids. And here you can see crude oil is the highest viscosity of fluid out of these 5 fluids. Here suppose the curve is transferred to here, suppose it is transferred to here, this curve is in it is coincide with the y-axis. It means this fluid is having zero velocity gradient, but the infinite amount of higher amount of shear stress. That means this curve, suppose if I take tau divided by du by dy is the quantity of viscosity. In this case, in this condition, the velocity gradient is equal to 0. Suppose if I put this value is to be 0, that means this value is to be infinitive. That means if viscosity is more infinity value, this fluid is like as ideal solid, and this case is an ideal solid. Ideal solid has infinity viscosity, so 0 velocity gradient, and shear stress is more here. In opposite to that, this curve is like suppose this quantity is 0, this quantity is having higher value. That means this value is equal to 0. That means 0 value. So if it is 0 value, shear stress 0, then velocity gradient goes and increases. This is the ideal fluid. So ideal fluid is having zero viscosity. Then ideal solid is having infinity viscosity. So this is what a Newtonian fluid says. So we have different curves. In the case of non-Newtonian fluid, we have different kinds of fluid. Say for example, same shear stress versus rate of shear strain or velocity gradient. See here, this is an ideal fluid as we have seen in the previous slides. In this fluid, it is a non-Newtonian fluid. This curve it behaves in a non-linear curve, and this non-linear curve, this fluid is called as a dilatant fluid, which means that this dilatant fluid is also called as a shear thickening fluid. That means when the shear acts, the fluid is thick. So example, corn with the starch. Whereas these two fluids are Newtonian fluid as described in the previous slides. So say for example, this might be a air and this might be in water, because water is having higher viscosity than air. That is the slope of this higher value here. So these are Newtonian fluids, and this one fluid it is a non-Newtonian fluid here. This is a pseudoplastic fluid. Pseudoplastic fluid means for example is nail polish paint. That means shear thickening fluid. Shear thickening fluid means, suppose the initially takes that fluid, if you take the fluid, it looks thick. When it shear it, the viscosity has been getting reduced. So that upper end viscosity reduced as the shear stress increases. That means shear thickening fluid. Example is nail polish and paint. You can see that example. And another one fluid, it is behave like a Newtonian fluid, but initially we need some stress to make the flow of this fluid. That initial stress, like some amount of field stress, is necessary for free to flow this fluid. This fluid is called ideal plastic fluid or Bingham plastic fluid. Bingham plastic fluid. So afterwards it behaves like a Newtonian fluid. It is a linear curve. So at point this real solid is having some amount of viscosity. That is why it is not coincided with this line is an ideal solid material. Ideal solid material having infinite amount of viscosity, whereas this is having some amount of viscosity. That means higher amount of viscosity, not that much in ideal solid, whereas here ideal fluid. This is called as a Newtonian and Non-Newtonian fluid. And this flow behavior of this dilatant fluid and pseudoplastic Newtonian fluid. Suppose the N is the flow behavior index. So this N is greater than 1 is for dilatant fluid, because it is a positive slope, and here N is equal to 1. It is N is equal to flow behavior is a linear, whereas here N less than 1. So these are fluid behavior. Here N is greater than 1, and it is a greater value of N value. So the flow behavior is here greater than 1. So these are the non-Newtonian fluids. These are the different non-Newtonian fluids: dilatant fluid and pseudoplastic fluid, ideal plastic fluid, several non-Newtonian fluids. And next, so this video describe about two kinds of fluid. As I summarize it, Newtonian fluid and non-Newtonian fluid. Newtonian fluid is having, it obeys the Newton law of viscosity, and non-Newtonian fluid, it doesn't obey the Newton law of viscosity. And Newtonian fluid are different. Example is air, gasoline, water, and mercury. Depends on the viscosity. The curve slope is a higher value. But the slope is more, that means viscosity is a higher value. Whereas slope is less, the viscosity is low value. Here less viscosity. But this point is slope getting 0. That means ideal fluid. Slope getting infinitive. This called ideal solid. And next is this non-Newtonian fluid. Non-Newtonian fluid, we have dilatant fluid, pseudoplastic fluid, and ideal plastic fluid. So then these are the types of fluids. And with this knowledge, I am sharing the Google link. So you can go to the Google link, or otherwise this QR code is available. You can there is a question, 10 question posted in this. Whatever knowledge you gained here, that you have to solve, answer these questions, and get their feedback. Thank you. This link also is present. This Google link is also present in my description box, so you can attend the questions and get more knowledge. Thank you. Thank you for watching this video. Thank you.